Alright, so what we're doing here is part A, and we're going to be testing the precipitation reactions of various anions and cations. So Jim, I'm going to let you run the show here.
So in your lab manual, you will find this data page.
Could you move it over just there? We go, that's good.
So what I set up over here corresponds to this page. So the idea here is we're going to add barium ions to all across here. So barium, we're going to react that with sulfate, barium with carbonate, barium with oxalate, and barium with iodate. So on our well plates, we think of our well plates matching up to this grid. So basically what it means, across the top, it's going to be barium, 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 and barium. And then below, we have calcium, magnesium, strontium, and then your unknown, which will be provided by your instructor. So on here, we're going to add across these four openings, going to be calcium, 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 and so on. That'll be magnesium, row number 3, strontium, row number 4, and then your unknown will go into all of these. Now, something I want to point out is that the bottles say barium nitrate. So we're looking for your barium ions. Barium nitrate is going to be the source of your barium ions.
They're all nitrate solutions for the positive ions, right? The
That's
barium,
correct.
the calcium, the magnesium, the strontium.
Yes, they are. We
nitrates.
have calcium nitrate, magnesium nitrate, and then of course we have strontium nitrate.
All right. So let's look at the sources for the anions.
Now the anions, notice I need sulfate, carbonate, oxalate, and iodate. So these are labeled as sodium sulfate.
Okay, could you bring it up to the camera a little bit? And you can see how it says Na2SO4. So don't worry about the Na part. That's just your counter ion. You're only interested in the SO4 part.
Right, and they're not going to be labeled as SO4 negative 2 minus, or CO3 2 minus, etc. They're going to be labeled with their actual names.
That's right, with what they actually are as solutions.
Okay, so now what I'm going to do, I'm going to take the well plate, and now I'm going to add barium across the top.
So how much are you going to put into the well plate in each case, Jim?
About
halfway?
Maybe halfway, yeah. It's not super critical, just try to be consistent.
Yeah, so maybe a third to half of each well plate, and just go across each one.
So that's about 15, 16 drops, give or take.
Yeah.
So let me repeat the same thing for this.
He's going to do it across the top there on that top row.
Now when you're working in the lab, depending on how the lab is laid out, you might want to let other groups have access to the bottles. Like, don't all run up to the hood or the station to do this, because this takes a little bit of time.
Right. Yeah, we don't want any bottlenecks. You could be doing the other part of the lab at the same time as other people are doing this part too.
So when I teach this class, I have half the class do part B, while the other half of the class does part A.
Yeah, I think that's smart.
Now I'm going to add...
Yeah, so you can see he's put the bariums all across the top there. Now he's going to do the calciums on the next row.
I mean, very careful not to contaminate the wells.
Yes. Yeah, he doesn't want to he wants to make sure he doesn't put any calcium in where he's put the barium. But you can see what he's doing here. All right, so we'll leave it at that for now, and then we'll show you the final result. So at this point, what Jim's done is he's put, could you show where the barium went? Barium went across the top, right, and then the calcium, right, and then the magnesium, that's in the third row, and the strontium goes in the fourth row. And then in the fifth row, you're going to put your unknown sample, just the same, exactly the same way as we did the other ones.
Okay.
Now what Jim's going to do is he's going to add in his first sample of anion. Now that's going to go down the first column.
Including the unknown, if the unknown was added.
That's right. So he's going to go ahead now and do that.
So I'm only going to add a couple drops to this.
Just a couple of drops? Okay, that's good. That should be all that's sufficient in order to get the precipitate, if there is going to be a precipitate. So he's going to go ahead and do that for all of these samples now. Then I'm going to show you the end result of each one.
And it's okay if these are a little different. Do not expect all of them to be exactly the same.
And some of them are going to produce precipitate, some won't. Some are going to produce a very thick precipitate, and some of them are going to produce a precipitate that's very fine, or even possibly hardly visible.
And I'm noticing these are all white precipitates? If you notice any other colors, I would suggest you start over and make sure you actually had a clean well plate.
Yeah, clean the well plate off first with water pretty well. You can use the sink if you'd like to clean it out with just regular tap water, and then rinse it off with DI water. That's the approach I think I'd take.
So I'm adding roughly 5 drops of
each anions.
Yes.
Yeah. So you can see what he did there. He ran could you say the anions again, please?
So again, the first row going down, that was sulfate. That's the SO4 on your data page. Then I've sodium carbonate. That's the second row down. Or sorry, second column down.
Yep.
The third column is the ammonium oxalate.
Right.
And then finally we have the potassium iodate down here.
All right, excellent. So I'm going to show what these look like here, and you can get an impression there of what's formed precipitates and what hasn't. And you'll have your unknown there, and you'll be able to compare your unknown. You can see that none of the results are exactly the same. They've all given something that's just a little bit different in each of these cases here. So to make this a bit clearer, I've actually put this on a black background here. Now if you look at the first and the fourth rows, you'll see that there is actually, if you look in that last one, there is a tiny amount of precipitate, but there isn't any precipitate in the fourth row. So we're going to add a little bit more just to that last one to see if we can increase the precipitate amount. And we have a little bit, so that's a good plan as well. If you're not sure if there's a precipitate in there, add a little bit more of the anion to that. And then we should have 4 unique results which can be compared to your unknown.
Okay, so this is part 2 for the ionic compound experiment. And we're going to be using bromine water in hexane, chlorine water in hexane, and iodine water in hexane.
Now we're only interested in the color of the hexane, which is going to be the top layer.
That's right.
So Jim's going to go ahead and make up those solutions now.
Okay, so I'm taking a test tube. And this is my bottle. This is labeled bromine water.
Could you put that, just put it down, there we go, that's good.
And I'm going to add...
Now you don't have to be that careful about how much you're adding here. Probably, what did you say, about a couple of fingers worth?
Yeah, maybe 2 squirts of this is all you maybe give or take of that. Just enough so you can see what's going on.
Yeah, could you just put down, there we go. That's a good amount. I like that. So that's which one's that? That's bromine?
That's the bromine water,
yeah.
That's correct.
Right.
Now, one thing about these solutions, they do tend to have a bad odor to them. So try to, cap the vials when you're done. All right, here's my hexane. So this one happens to be labeled as heptane, but it doesn't make any difference.
Yeah, it could be heptane, could be hexane, could be cyclohexane in some places.
Right.
In any case, it's just an organic hydrocarbon that's going to be used to show the colouring here. Now, this is always going to be on the top layer. Go ahead and add that. How much are you going to add? About 2 squirts again?
Yeah, there. One squirt actually seems to be reasonable here.
Okay, fair enough. So let's bring that over here now. We got a cap here. Could you go ahead and put the cap on, please? And push it down a little bit. And sorry, down the shot. There we go. You can see we've got a cap on there. We can shake it around.
So we notice after I shake it a couple times, the top layer is a little bit different than the bottom layer.
Yeah, you can see now that top layer's gone that orangish color. It's almost like the color of the bromine has been transferred into the hexane layer, which is the top layer, of course.
We only care about the color of the top layer.
That's all we're interested in.
Ignore the bottom layer.
Ignore the bottom layer. Just look at the color of the top layer. That's good, Jim. So what Jim's going to do now is he's going to put that off to the side. He's going to clean the stopper now in some water. He's just got some water there. He's just cleaning off that stopper so he can use it again for the next solution. All right, let's go ahead and do the next solution.
Okay, so now we're going to run the chlorine water in hexane. And just like before, we use roughly 2 squirts of the chlorine water. That's about right.
That's about right, yeah. Now you'll notice the chlorine water could be almost colorless, but it should have a very, very, very slight yellowish tint to it. Let's go ahead and add the
And I also
hexane.
notice here a very typical chlorine odor you might get at a swimming pool. A very similar type of odor I'm noticing with this. And again, I added one full squirt of the chlorine water. Sorry, of the hexane. And I notice in this case, there's, after shaking,
Yeah, we'll put that down in front of the camera here. And you can see that, yeah, I can smell it from here actually, that chlorine.
Yeah.
You can see in this case, it looks to be pretty much colorless. But as I said, sometimes you'll see a very slight yellowish tint to that top layer. Remember, we're only interested in the color of the top layer. And that's the one that Jim's talking about there. All right, let's look at the next one. So the next one's the iodine water, right?
that's correct. So I'm going to rinse the...
So he's going to rinse that stopper again. And he's getting a clean test tube and he's going to add some iodine water, about the same amount as what he did before.
again, roughly 2 squirts.
That's right. Now you'll notice the iodine water is a pinkish color?
Not right now. It's
Not right
kind of
now.
an orange.
Orangish. Okay. Right. So it's an orangish color on the bottom part. Now we're going to go ahead and add the hexane to this. As I said, it could be hexane, heptane, cyclohexane.
Yeah, I added 1 squirt.
Yeah, it looks like I preempted myself here. It looks like the top layer turns this pinkish color. See, that's why we're only interested in the top layer. Could you put that down in front of the camera? There we go. Take a look at that top layer. Really clear that it's a very nice pink color. It's good. All right, thank you.
Okay, so now we're moving on to part B from part 2 of the ionic compound lab. And if you notice here in the data table, it says them to react Br minus with Cl2, Br minus with I2, but notice it says Nr for Br minus and Br2. And that means no reaction. So there's no need to attempt to react Br minus with Br2 because something is not going to react with itself. It's basically what that's saying. Likewise, Cl minus with Cl2 and I minus with I2. So you only need to react things which are different. Now at the bottom, X minus, that corresponds to your unknown. Now something I want to point out here is that whatever unknown you use in part 1, make sure you use the same unknown for part 2. Otherwise the results will not make any sense later on.
Now you've got to remember that your unknown consists of 2 parts, a cation and an anion. You're analysing the cation in part A, you're analysing the anion in part B. And your anion will be either one of Br minus, Cl minus, or I minus. Your cation will be one of magnesium, calcium, strontium, or what's the other one?
Oh.
Magnesium, calcium,
Barium.
Yeah, barium, strontium, calcium, or magnesium. And so that's why it's important to use that same unknown.
Right. So if you pick unknown number 1 for part A or for part 1, make sure you use unknown number 1 for part 2.
Yeah.
Just be consistent with whatever you choose.
That's great. So now Jim's going to go ahead and he's going to put some stuff together here.
Okay. So now if you notice at the back here, I have sodium chloride. Now that's going to be my source of Cl negative. Again, just like in part 1, the bottles are going to be labeled the actual compound. It will not just say Cl minus.
It's really important to not mix up Cl minus with chlorine water. Chlorine water is Cl2, NaCl is Cl minus.
Again, we have sodium iodide. That's going to be the source of I negative. And sodium bromide is going to be my source of Br minus.
Now, could you put that down the camera a bit more? There we go. That's your NaBr right there. Thank you.
Okay. So now I have a test tube. And I'm going to add approximately the same amount of the halide waters as I did before, and a similar amount of the corresponding, the appropriate anion.
And then we're going to put hexane on top of that as well. And we're only interested in the color of the hexane layer, the top layer.
That's right. So I'm going to work across the top with Br minus and chlorine water. I'll start with the chlorine water first.
Here's the chlorine water.
Chlorine water.
He's going to go ahead and put that in.
Again, a couple squirts is all you need.
Yeah.
And now I'm going to need the bromide, Br minus.
So that's where he's going to add the NaBr. That's good. And again, be very careful not to mix up the NaBr with the bromine water. They are two different things.
Since it doesn't have a stopper, I'm just going to squirt a little bit in.
Yeah. Now we're not really interested in what's going on
Good enough.
initially. Now we're going to add some hexane to it, and we're going to see what goes into the hexane layer.
All right. So I'm going to squirt a little bit of this in. Again, roughly a finger's width is probably fine. 1 or 2 squirts would be good enough. Maybe a little bit more than that. Something like this. So I'll show the camera.
So he's rinsed off the stopper here, so he can put it on. And we've got the hexane in there along with the. There we go.
Now I noticed this particular.
Could you put it down the camera a bit?
This particular test tube is a little bit bigger than the others. This don't let the stopper fall all the way through.
Yeah. And make sure you're using the appropriate size stopper. Okay, go ahead and put that down in the camera a bit more. And I want you to look at the color of the top layer. That's really going to be important here. We're not going to say what that color is. I want you to make that observation yourselves.
And the idea is that you want to compare this color to your standards, which we just did a little bit earlier.
That's right, but remember, we're only interested in the top layer color.
Right.
The top layer, which is the hexane. Okay.
All right, so now we're going to do iodine water with the sodium bromide. Again, I'm going to add a couple squirts. And I also want to point out, you really want to make sure you're wearing gloves when you're doing all of this. There's iodine water. And now I need sodium bromide. So last time I squirted in maybe 15 to 20 drops. I'll just do the same thing here. Squirt a little bit in. Good enough.
So again, we're not interested in the result right now. We're only interested in the result once we add the hexane to it.
And shaking it.
So he's going to do that now. And then we'll be really interested in what happens with that hexane layer.
Alright, so I added the hexane.
Right. Now he's got a clean stopper there.
Stopper on.
And he's going to go ahead and shake that up a bit. Let's put that in the camera. Okay, I want you to take note of the color of the top layer.
Okay, so now I'm going to do, now we completed the first row. Now we're going to do Br2 with Cl minus with the hexane. So, that bromine water.
Yeah, so that's the Br2, the source of Br2.
Get a couple squirts.
Right, and now you're going to add Cl minus.
Add sodium chloride. That's the Cl minus.
And again, we're not interested in what we're seeing here. We're just interested in what happens once we add the hexane. And we'll get an idea.
And now we'll add our hexane and see what it does. Stopper, and we'll shake it up.
Alright, let's bring that into the picture here. And again, take a look at the color of the top layer. That's all we're really interested in here.
Alright, so now we're going to react iodine water with the sodium chloride.
Alright, so I2 is iodine water or iodine water. And to that we're going to be adding sodium chloride solution. And again, we're not really interested in the result of this part, just what happens after we add the hexane. So it's adding sodium chloride now.
And now
Now the hexane. Okay, so now you can take a look at the color of the top layer there. Alright, very nice, thank you.
Alright, so now we're going to react bromine water with the sodium iodide. Adding a couple drops, a couple squirts of the bromine water. And we'll add a little bit of sodium iodide to it.
Alright. We're not interested in what happens here, just what happens once we add the hexane. So again, look at the color of the top layer here, and that will tell the story.
Alright, so now we're going to react chlorine water with iodine. So add a couple squirts of this. There's my sodium iodide.
So remember, we're not interested very much in this result here right now, but now once we add the hexane,
so about a squirt and a half of this,
and we'll be interested in what this top layer becomes. Alright, so again, look at the color of the top layer here, and that will tell the story.
Okay, so now we're going to, the last step will be to run our unknown. Again, whatever unknown you used from part 1, use the same unknown solution for part 2.
A little bit down, there we go.
So we're going to react bromine water with our unknown. We'll add the hexane, shake it up, look at the color of the top layer. We'll add chlorine water with our unknown, add the cyclohexane, shake it up, look at the top layer, and then we'll also repeat them with iodine water with the unknown and the hexane, looking at the top layer.
There you go, and that will allow you to determine what your anion is in your unknown.